Yeah, now we have this theorem. So let me write it down. So say let C be an element of a real number. Then we have the limit as n approaches infinity of a of n, which is equals to L. And we have the limit as n approaches infinity of Bn, which is equals to M. Right? And then the first one, they say the limit as n approaches infinity of C will be equals to C. Right? So for us to prove this, I'm going to write proof. Then I want you to know this. So I'm going to write proof. Then I write let epsilon greater than 0, because we want to prove that this exists, right? We let an epsilon be greater than 0 and say they exist n. Since this is alone, you can just let it be n. So that they exist n is an element of a natural number. Say such that for all you know that n should be greater than n. Then this would imply that the absolute value of c minus c, c is our f of x, then c is our L. C, this will be less than E. You agree, right? And this would imply that we have the absolute value of 0 is less than E, and this would imply that 0 is less than E. And initially we say that E is greater than what? 0. So this is true. You see, right? Say hence the limit as n approaches infinity of C will be equal to C. So let's come to the second one. We come to B and we say B is saying the limit as n approaches infinity of an plus bn, which should be equals to, here we say that L is equals to L, right? A of n is equals to L plus m. We see, right? Then we can prove this. I can come and say proof like that. Then first I let E be greater than 0 and say they'll exist. We agree, right? They'll exist n, which is an element of a natural number, such that for all n greater or equals to, I can say greater than L, this would imply that the absolute value of an plus bn minus L plus m would be less than E. So this is what we should arrive to. We agree right now. So this is what we should arrive to. So for this proof, I just want you to write this aside. Always, even here, just that I didn't want to write this aside, but first you need to write this aside, and then I'm gonna show you how to do it properly. Because mostly they don't want you to write this in full, because you are just saying that this thing already exists and you're supposed to prove that it exists. So what you're going to do, you're going to start here. You see, right? You're going to start here. So for us to start there, we're going to say we have the absolute, value, of a of n plus b of n minus L plus m which is equals to a of n minus l plus b of n minus m, right? Which this will be less or equals to a of n minus l plus b of n minus m. So we can start like that. We agree, right? But then we need to know what is this and what is this, right? So now we're going to start here. We're going to say, since we know that we have the limit as n approaches infinity of a of n is equals to l. We agree, right? And then there will exist, we can say n, and we're talking about the n of l, is that right? Which is an element of a natural number, then I say such that for all n greater than n of l, this would imply that the absolute value of a of n minus l will be less than, I can say, e over 2. And then I say and, now I say since the limit as n approaches infinity of a of n, the other one is m, right? So I'll say they exist, it's b of n, this other one, b of n equals to m. I'll say don't exist n element of m, there don't exist n of m element of n such that for all n greater than n of m, this will imply that the absolute value of a of n or b of n minus m will be less than a over 2. You see, right? Now I know what is this, I know what is this. And check this. I've used this definition first, then I came to this one, then now I'm coming here. You see, right? So to come there, I must let n be equals to, you see, right? So I must let this be equals to, it's going to be max, then I'm going to have, because the same that this will always be the solution, it won't change, right? We're going to have n of l, n of m, which obviously this is greater than 0. We agree, right? So from this case, now we can go back here and we say the absolute value of an plus bn minus l plus m, this is less or equals to, already we know that, right? So I'm just going to write this, an minus l plus bn minus m, and this will be less than, since we know this is e over 2 plus e over 2, this would be equals to a, right? Hence I've proven this. So I can write plus the limit as n approaches infinity of a of n plus b of n will be equals to l plus m. Then I want you to try this. I'll say try the limit as n approaches infinity of a of n minus b of n which is equal to L minus M. So try this. I want you to try that. So, and then we have the third question, which I'll do it on its own. I think, let me see this. Yeah, we have C. Let me just do the last one. C. Just do C. Just do C. See, we have the limit as n approaches infinity of an bn, which is also ab. No, it's lm, right? And we know this, right? We know that for each or for all e greater than 0, there will exist n element of a natural number, right? Such that for all n greater than n, this will always imply that we have the absolute value of an bn minus lm, which should be less than e. So this is what we must prove. Then first I say that I'm going to start with the absolute value. So I'm going to start with the absolute value of an bn minus lm, which this will be equal to. So here I need to take the opposite. You know that bn is equal to what? M, and an is equal to l. So I need to take the opposite. I need to take, either I take this and this, or I take this bn and this l. No, I pointed the wrong things. Not exactly, because I need to take the opposite. Let me point to the opposite. I need to take this and m, or b and this. You see, so I'm taking the opposite. I know an is equal to l, but I won't take al and l. I'll take an and m. So I'm gonna take the opposite of this and multiply them, then add there and subtract. So I'm going to take, so I'm going to say an bn, and then I subtract. So I'm going to subtract an times m, add an times m. You see, right? And then I subtract my lm. Then this would be equals to absolute value of, or instead of saying equals to, you can just use the triangle inequality. So this will be less or equals to an bn minus an m plus an m minus lm, which this would be equals to, I fix out an bn minus m plus I fix out m an minus l, right? So I have this. Now I know that I need this, and I need to know what is this. You see, right? So now I can come and say, since, let's start with bn minus m, or we can start with an. We say, since the limit, or instead of using the limit, we know we can easily find am, because here we're dealing with something, we're dealing with m this side, you see. So this can easily become simple. We know we have this thing that says for boundedness, right? If you want to treat if a sequence is bounded, you can say a of n is said to be bounded if the absolute value of a of n is less or equals to m. You see, right? And again, we know that the absolute value of m will always be less or equals to the absolute value of m plus 1. You see, right? So that will always be the case. So now let's check, since we know what is a of n, we know what is the absolute value of m. Now let's check bn minus m. So I'm going to say this. I'm going to say since the limit as n approaches infinity of bn is equals to m, then this would say the absolute value of bn minus m would always be less than, this is always less than a over 2, right? But when we look at the value that is associated with bn minus m, it is m. So we can manipulate the denominator to m so that m can cancel. You see, right? And then I say, and since the limit, so this limit is as n approaches infinity of an. Now I'm checking this one is equals to L. Then the absolute value of bn minus, is it an, not bn? Of an minus L will be less than e. It's always e over 2. But we have this, right? And this will be m. So this was supposed to be like this. I can remember here it is m, right? So it was supposed to be like this. But when it's like this, we might face a problem. But it's fine also. So we're going to say plus 1 here. So I just want to find ourselves manipulating. Since we manipulated this, and we have this sign less or equals to, I want us to also manipulate this one. So we can have the sign less equals to. So the sign can be compatible for both expressions. So I just manipulated this denominator to be the same as this. So I'm going to go back now and say the absolute value of an times the absolute value of bn. Yeah. I'll start there like this. I'll say absolute value of bn minus lm. This will be equals, already we know here, right, what it will be equals to. We know it will be less or equals to an bn minus m plus m an minus l. And this is less or equals to, right? What is our a of n? A of n is m. B of n is e over 2m plus our absolute value of m, it's absolute value of m plus 1. And our a of n minus l, it's 2 over 2m plus 1. Right? So this would cancel this. So we're left with e over 2 plus this cancels this. Then we're left with e. Should have written e here. I don't know why I didn't write e. And this is equals to what? E. Hence, we have proven, the the limit as n approaches infinity of a of n bn will be equal to Lm.